All right, welcome back. So this is 10.6, talking about the polar form of conic sections, where you'll see we've got four main equations we're going to deal with for the polar equation of a conic. We have r equals ed over, and then the denominator is always either going to be, we have four options: 1 plus e cosine theta, 1 minus e cosine theta, or 1 plus e sine theta, or finally 1 minus e sine theta. Both e and d are both always positive values. E is referring to eccentricity, and D is referring to the directrix. Now, the type of equation you're dealing with for the directrix is going to depend entirely on the original polar equation. You're noticing, again, numerator is always ED, so that's not really the relevant part. It's the denominator. If the denominator is in the form of 1 plus E cosine theta, it's x equals D for the directrix. If it's 1 minus E cosine theta, it's now minus there. Now it's x equals negative D. So cosine denominator gives you an x equals positive or negative cosine tells you it's positive or negative d. And then same thing with the y equals directrix. It's now sine in the denominator. Sine is positive, it's positive d. Sine is negative, it's negative d. Now the eccentricity is just simply defined as the distance from any point to its focus divided by the perpendicular distance from that point to the nearest directrix. This is used to kind of create your conic equations. And we have our three main conics: ellipses, parabolas, and hyperbolas. The circle doesn't really count for this because the the eccentricity for a circle is 0. But anything beyond 0 tells us which type of whether it's an ellipse, parabola, or hyperbola. 0 to 1 is the ellipse, equal to 1 is the parabola, greater than 1 is the hyperbola. So what we're going to be doing for these kind of problems, we'll be determining the eccentricity, type of conic, and the equation of the directrix from this given information. And the key is it needs to be in the appropriate format, which every single one of the equations had ED up top, so 9 represents ED, but the bottom was always either 1 plus or minus and then E cosine or sine. So we need to make sure it's always a 1, so whatever this number is right here has to factor away from the entire expression. Whether it factors nicely or not is not really relevant. It has to factor completely. So we take 3 away from 2.25 and we get 0.75. And then it has to reduce the numerator, whether it reduces nicely or not. So 9 over 3 becomes a 3. So now we are in the format of ED over 1 plus E cosine theta. So the E is always the number in front of the trig function. So E is 0.75, which means we are dealing with an ellipse. As for the value of D, well, the numerator 3 is equal to E times D. So we get D to equal 4 in this case. So that's our directrix value. The equation for the directrix, because it's a cosine equation, is going to be x equals. And because it's a positive cosine, it's the positive value of D, so it's positive 4. And that's all we're looking for right there, where again, this last thing is the equation for our directrix. That's our process. Factor the number away from whatever is adding or subtracting on in front of that trig function to then figure out the numerator in its appropriate format, the appropriate number in front of the trig function, all that kind of stuff. Sometimes we have to rearrange the equation to put it in the right order. So this would really be a negative 2 plus 4 sine theta. So we're going to factor away the negative 2 to get 1 minus 2 sine theta. That reduces the numerator again, 8 up top. And again, the number in front of the trig function is E. The negative just tells us the type of function we're dealing with, so we don't consider E as negative 2. It's always a positive 2. Since that's greater than 1, we're talking about a hyperbola. As for the directrix value, ED, 8 is going to equal E times D, which means D is, again, 4. Because it's a sine, the directrix equation will be y equals, and because it's negative sine, it will be y equals negative 4 for the equation of our directrix. So if I'm giving you the equation, I want eccentricity, type of conic, equation of the directrix, that's what I'm looking for. We're not looking to graph these things. If I'm graphing conics, we're going to graph them like we did in Unit 8. It's a much more recognizable format to graph the ellipse, parabola, and hyperbola in that kind of format rather than a polar format. The only conic that's nice to graph in polar format really is the circle, when it's just r equals a number. Now, I might also ask you to write the equation of the conic based on this kind of information. So being told E is 2 and the directrix y equals 4, This tells me d is equal to 4. So our equation is going to be r equals, ed is always the numerator, and the denominator is going to depend entirely on the directrix information. It's always going to be a 1. Now, whether it's positive or negative is based on whether the directrix is positive or negative. So the directrix is a positive 4 here. So it's going to be a plus our e value of 2. And then because it's y equals, it's going to be sine theta. And as for the numerator, since e is 2 and d is 4, 2 times 4 is 8. So it's 8 plus 8 of the numerator, sorry. And then 1 plus 2 sine theta in our denominator. So that's kind of how we're working through this. ED is just simply the E times the D numerator, very simple. And then whether the denominator is going to be 1 plus or minus is based on whether the directrix is positive or negative. And sine or cosine based on whether it's y or x equals. So let's make a slight alteration. Let's say that's x equals negative 2. So E is 1, D is 2. Doesn't care that it's negative, that just shows the type of equation we're dealing with. Where the type is ED over 1 minus E cosine theta. 1 times 2 is 2, so the numerator is a 2. And it's going to be 1 minus 1 cosine of theta, which we don't really need to write a 1 cosine theta, but we're welcome to. And also, we did want to classify, so this was a parabola, because E is 1. If I go back, this should have been a hyperbola, because E was positive 2. All right, so that's all we're really working with the polar form of the conics. Again, can't really graph these things in a meaningful way just because the equations themselves are a little bit more obnoxious, at least doing it by hand. It's more about classifying and writing out the equation for the given information. All right, one more topic here in Unit 10. There's going to be a lot of different formulas involved with using the polar functions and the complex number that gets into this scenario. So I'll see you guys next time for that video.